Hello everyone. I hope you're having a good weekend. As promised, I wanted to work through your homework in its entirety so you would know how to do it. So this is the homework from Chapter 9, 2, 4, 6, 8, and 10. The three equations you'll be using are the definition of torque, which is torque equals perpendicular distance times force, and the conditions for equilibrium. That's the clockwise torque equals the counterclockwise torque, force up equals force down. Now I'm going to toggle back and forth between the the Microsoft Word document and the homework so you can have a look at it. The first problem is number 2. It just says calculate the torque about the front support post. And you can see that the front support post at B is 3 meters away from the diver, and it's a 58 kilogram diver, and it's 3 meters from the post. So you're just using this formula, that the torque is equal to the perpendicular distance times the force. So the perpendicular distance, here I'll just work it out in here. So the perpendicular distance, we still have torque. So torque is equal to the perpendicular distance, which is 3 times the force. Now it's a weight, so remember 58 kilograms is the mass, and we still need to include the acceleration of gravity when we deal with the weight. So that's equal to 3 times 58 times 10. And that's going to give us 1740 Newton meters. So you write it this way, just Newton times meters, like that. That's all it is for number 2. Looking at number 4 says, let me move it so you can see. Okay, number 4 says, how far out on the diving board would a 58 kilogram diver have to be to exert a torque of 1100 meter newtons? So when they say meter newtons, that's the same thing as Newton meters. It's no difference on the board relative to the left support post. So our distance is going to be relative to the left support, but it's the same equation. And I'll work it out here as well. Here they've given you the torque. So they've given you that the distance, well, that the torque is 1100, and they're asking for the distance. The force is still going to be the same, which is 580. So you get 580 divided by, 1100 divided by 580 gives you 1.9 meters. So the answer to that question is 1.9 meters out. Now that's right about here. So because it's 1.9, sorry, it's 1.9 there. It's about 1.9 meters from A. So you're measuring from A. So that distance right there, that distance should be 1.9 meters. Yeah, I mean that you don't need to know that for answering the questions. The answer is just 1.9, but to understand what it means. Number 6 says calculate the forces FA and FB that the supports exert on the diving board when the person stands at the tip, when you ignore the weight on the board, and when you don't ignore the weight on the board. So here, this is meant to represent the board, and you've got 3 forces acting. And one of the forces, so this is for number 6, one of the forces is the weight, and weight is always down. So that's the weight. There. You've got 2 other positions. You've got FA here, somewhere here, and you've got, sorry, this is FB, and you've got FA there. Now, in order for the equilibrium to occur, the forces on the outside have to be in the same direction, and the forces on the inside needs to be up. That's if you've got one inside force. And that's because if you imagine that you pivoted right here, if you imagine that you put the pivot right at the end, if you've got a downward force on the far right side, you've got to have an upward force here in the middle. Likewise, if you pivot it right in the middle, you've got to have downward forces on both sides, otherwise it's going to flip. Just like if you try to push down a pencil on the ends, holding your finger in the middle, the finger in the middle has got to be an upward force. So this one is FA. I'll do this with a text box. So this is FB here, resize this for you. This is FB, because that's where post B was. And then this one is FA. It's not letting me do that. This one is FA. And then the weight is over here. So now we apply the conditions of equilibrium. And there are two. And you can do them in either order. So the first condition for equilibrium is that the force up equals force down. So we're going to do A right here. Now force up equals force down. The upward force is FB. And the downward force is FA and W. So we've got FB equals FA plus W. Now the W is the weight of the person, so that's 580. So we get FB equals FA plus 580. Okay, and then to calculate, so that's one equation. We need the other equation as well. That's the torque equation. And before we use the torque equation, we have to establish a pivot. So we have to place a pivot on the system. I've told you in class that pivot can be anywhere because the torques need to balance around any point. But it's usually easier to put the pivot on something that you don't know. So I'm going to place the pivot at FA. And the pivot just means that's the point around which you're going to calculate the torques. So I'm going to put a pivot right here. Darn it. It's messing with my diagram. There. So look, these things, they're all in the same place, all right? Can you buy that? There, that's better. There. Now I got it right. So they're all in the same place. And now your pivot doesn't have to be there. That's just where I put it. So if that's where our pivot is, the FB is causing a torque that is counterclockwise, and the weight is causing a torque that's clockwise. So we're going to put this here. So the clockwise force is from the weight. The counterclockwise force is from the FB. The weight is 4 meters away, so we have 4 times 580. And FB is 1 meter away, so we have 1 times FB. So that gives us FB is just 4 times 180, which is 2320. And that's newtons. And if you want to find FA, you go back to this other equation that you had, where you had FA related to FB. Now you know FB is 2320, so you get 2320 equals FA plus 580, and so FA is 1740. Okay, now for part B of this problem, the only difference is that you now have a weight. And the weight always acts in the center of an object. So you have an additional weight now. And the additional weight is from the, there. The additional weight is going to be right in the middle. And that's the weight of the board. So that's going to be 350 newtons. So I'll indicate that here. That's 350 newtons. So what that changes is, so I'm just going to copy this one first. We'll leave the pivot in the same place. Instead of having the clockwise torque being just the weight, it's going to be also the weight of the beam, which is going to be 2 times 350, because the weight acts in the middle, and that's 2 meters from FA. So that's going to add 700 newtons to FB, so that makes FB 3020. and then we can go back and find the new value for FA. Oh, sorry, did the wrong one. There. So what's different now is, so we did the torque equation first, so what's different now is, instead of having just the weight of the person, we have the weight of the bridge, or the weight of the board. And so that's going to be plus 930. And in this case, FB wasn't 2320, it was 3020. And the weight is 930. So our FA in this case is going to be 2090. There. All set. Now we move on to part 8. Number 8. Number 8, 140 kilogram horizontal beam is supported on each end. A 320 kilogram piano rests a quarter of the way from one end. What's the vertical force of each of the supports? This is a real similar problem. I won't draw a diagram for interest of time because I have to try to get this done in 15 minutes. I will copy this though. So force up equals force down. We have two upward forces, which are, we can call those the ends. So you've got F1 plus F2 equals the downward forces. And the downward forces, there's two of them. There's 140 and then a 320, and they're weights. So it's 1400 plus 3200 because we take the mass times 10. So you get F1 plus F2 equals 4600. There. Now when we calculate the moments, so we put the pivot at the left. We know that that the piano is it says the piano is a quarter of the way apart. So the distance for the piano is going to be equal to 1/4 of the total distance. Well, I'm just going to call it 1. And the distance for the beam is going to be half the way apart. I'm going to call it 2, so that way the whole thing is 4 meters across. And that should be as good as anything. So we'll pivot it on the left again. Again, I'll take this one. So in this case, we have the clockwise force being caused by the weights. So we've got the 3200 times 1 plus the 1400 times the 2 equals F2 times 4. So that's that gives us F2, if you work it out, is equal to 1500. And then we can go back into the other equation where we saw they added up to 4600. Now we know F2 is 1500. So that gives us F1 is equal to 3100. There. Okay, one. Okay, so in the interest of time, because we're almost out, I just wanted to show you how to do number 10. I've worked it out here for you. So the bottom line is that you have to put the weight right in the middle. So that's at 25 meters from the end. That's where the 12,000 newtons acts. That gives you FB of 15,000 newtons upwards. Now, when you go back into the force equation, you do get negative 3,000 newtons for your force, but that's because they drew the arrow in the wrong direction. They drew it up. It should actually be down. A negative force just means a force in the opposite direction from when it's drawn, because force is a vector. Okay, I think you've got everything now. Have a good weekend.